Okay, Algebra 2, this is Trig video number 3. And I'll write that down here in a second. We're starting out by using this 30, 60, 90 right triangle. You'll notice that the side lengths I've labeled 1 for the hypotenuse. We know that to go to the short leg, we cut that in half. We know to go to the long leg, we multiply that by radical 3. So I have 1/2 for the short leg and radical 3/2 for the long leg. Okay, and this is a triangle which is movable, so I'm going to be moving it around however I feel like it, so you might see it written like this, but the side lengths are still the same. Likewise, you might also see me using a 45, 45, 90 right triangle with the hypotenuse being 1 and the side lengths both being the same. We would divide by radical 2, and then rationalizing that as we did in class, we would come up with radical 2/2, and also as we did in the notes. So let's start with this unit circle. Let me back it up here a little bit. We're on Trig video number 3 for the unit circle, and here I'm going to bring in this triangle so that you can see that dealing with a 45-degree angle, there is a point out here on the circle. Now that point on the circle has an x value and a y value. Now if you follow the legs of the triangle, you would see that that is an x value of radical 2/2 and a y value of radical 2/2 also. Now, that is tied to 45 degrees. So, if I'm asking you for the cosine of 45 degrees, you can tell me that answer. If I'm asking for the sine of 45 degrees, you can tell me this answer. Now, I realize that those two numbers are the same, but remember that cosine is the x value and sine is the y value. Now, I'm going to use this triangle, and I'm going to find 3 other places that have x and y values that I can easily identify that are based on this triangle. So the first one of those values, if I pick this up, is over here. You are going to notice that it's still the same 45, 45, 90 right triangle. And right there is a point. And it has an x value and a y value. Now the x value in this case is negative, but the y value is positive. So using the triangle, I go negative radical 2/2 to the left and positive radical 2/2 up. Now, what is the angle measurement from here to here? Now, it's based on 45 degrees, but it's not 45 degrees. It's this angle here, starting from 0, coming around to that spot. So, if you took 180, which is over here, and you subtracted 45 degrees, you would get 135. So, these two things right here are cosine 135 degrees, sine 135 degrees. Cosine being your x, sine being your y. Okay, so now we're going to move into the bottom part. Alright. Same triangle. but now it's in the bottom part. Still a 45, 45, 90 right triangle. There's a point out here. It has a negative x and a negative y. So we have negative radical 2 over 2, comma, negative radical 2 over 2. Now what's the angle measurement? Now remember, the angle measurement starts at 0. It's got 90, 180, plus another 45. So this is 225 degrees. So this is the cosine of 225 and the sine of 225. The last one of the ones that are based upon this triangle is over in quadrant 4. Keep in mind, we're still dealing with the same 45, 45, 90 right triangle. It's got a positive x value and a negative y value. So this coordinate is positive radical 2 over 2, negative radical 2 over 2. And so this is the cosine of some angle. Well, let's figure out what angle it is. It's got 90, 180, 270, plus another 45 degrees. So that would be 315. And this also would be the sine of 315. So, there we have the unit circle based upon the 45-degree angle measurements. Okay? Those four go together, all based upon which quadrant they're in and the side lengths of the 45, 45, 90 right triangle. Well, now we're going to switch to the 30, 60, 90 right triangle. Okay? I'll start with a fresh circle. Now that you've kind of gotten the hang of it, maybe I'll go around and just do the angle measurements first. Okay? 30 degrees is here. 60 degrees is here. 90 is at the top. There's 120 degrees and 150 degrees. You notice I skipped these, the 45 and the 135. 180. 200, 210, what am I thinking? Add another 30 and we have 240, 270, 300, and 330. Well, I'll start out with the 30, 60, 90 right triangle. It's got a positive x value and a positive y value. It looks like this side length is radical 3 over 2 and this side length is 1/2. So that's the coordinate, radical 3 over 2, 1/2. Likewise, there are 3 points to go with that one as well. For instance, I could jump over to quadrant 2. The 150-degree mark has a negative x value and a positive y value. So you're following along the bottom here. Negative radical 3 over 2, positive 1/2. (210) also goes with it, right? It has a negative x and a negative y. That would be negative radical 3 over 2, comma, negative 1/2. And 330 also has this reference angle. Positive x, negative y. So this would be positive radical 3 over 2, negative 1/2. Well, what about the 60-degree angle? The 60-degree angle uses the same triangle, but it has an x value of 1/2, positive, and a positive y value of radical 3 over 2. And there are 3 others that go with that one too. For instance, 120 degrees. 120 degrees has a negative x and a positive y. That's negative 1/2 and positive radical 3 over 2. You could be down in this quadrant at 240. That's got a negative x and a negative y. Negative 1/2 and negative radical 3 over 2. We could also be at 300 degrees, right? Which has a positive x and a negative y. So I can literally start asking you questions in class based upon these circles, cosines and sines of these different points, not just the 90, the 180, the 270, the 360, but those are the kinds of questions in class we're going to talk about, is places on the circle and understanding their x's and their y's. And we'll just stick with x's and y's for right now. See you in class.